I have a question. Which one is your favorite scientist between these two? Right, so you've got Nikola Tesla on my right with alternating current, and you've got Thomas Edison on the left with his DC current. Well, which one's your favorite? Mine's a clear winner for Nikola Tesla. He invented alternating current, and every time we go on a train, every time we accelerate on that train and hear those little engines run, that's Nikola Tesla right there. Now, obviously, DC current has its own little good situations too, but of course it does. But Nikola Tesla's my favorite, and I wanted to talk about Tesla because there's a little article that came out recently about a century-old water valve invented by Nikola Tesla that could have more modern uses. Very interesting thing. This is what it looks like. This is the water valve right here. So you may be wondering, who is Nikola Tesla? Well, let's quickly show you. There was a very interesting article called The Tesla Files. A very interesting show. I ended up watching that with my girlfriend Vicky. A great show. Also, Tesla, the car company. Well, the car company has nothing to do with Nikola Tesla. And Nikola Tesla has nothing to do with the car company. But, you know, Elon Musk and the other founders of the Tesla car company named the car company after him, I guess you could say. So, you know, he's a very old dude. He would be if he was still alive. He'd be, you know, probably 200 something. But yeah, this water patent came out about 100 years ago, 101 years ago. Let's discuss it right now and see the potential uses for this new technology, for this patent that's been around for a while. But potentially, new technology can be invented from this thing. And this is what a Tesla valve is, right? So let me show you a more clear picture. So if water flows from this way, on the very top one, if water flows from the left to the right, as you guys can see, the water is going to get trapped in the red zones, and it's going to create, you know, water friction, I guess you could say. And it's basically a one-way valve. It doesn't fully stop the water, but it prevents it, a lot of it. I think it's roughly half of the water. But if the water comes this way, the water easily flows. And yes, it does go around here every now and then as well, but the restriction is much less. So that's how a Tesla valve kind of works. Now on the top, you've got the fire going through very fast. Now if you flip the board around on the bottom, see how the board is kind of flipped around? By flipping the board around, there's now resistance with the fire because they're using flame in this obviously this situation, and it takes a lot longer for the flame to reach the other side. So it's basically a one-way valve that slows down the substance that's going through, water, fire type thing. But yes, it has different purposes, like a jet engine type thing. This could be used for like a pulse jet engine kind of thing. And this is another engine design where we can have the Tesla valves in there. But yeah, let's read this quick little article and see what you guys think. So a one-way water valve with no moving parts, invented over 100 years ago by Nikola Tesla, could be adapted to pump fluids around motors using otherwise wasted energy. This is such an interesting article. Tesla patented his valvular conduit in 1920. Wow, so 101 years ago. It is essentially a pipe with an intricate design, internal design that forces fluid moving in one direction to loop back on itself at various points along its length. Now, when water flows into the mouths of the loop, it becomes turbulent and slows down, halting the flow. But if you run the water in the other direction, it doesn't enter the loops and it flows freely. Well, it does enter the loops, but it doesn't enter it in a vigorous manner. That should have been written down there, wrote down there, whatever. Jeff, what's his name? Leif Ristroff. What's his name? Let's quickly search this for you. Leif Ristroff, I got that correct, at New York University, and his colleagues built a 30-centimeter long version of the valve, following Tesla's original plan, and measured the flow in both directions at a variety of pressures, right? Now, although Tesla claimed in his patent that the valve could make water flow 200 times slower in one direction than the other, the researchers found that their version only made it 2 times slower. He was a very imaginative guy, says Ristroff. It's a little unclear whether he actually made and tested it. I suspect so, but there's no documentation of that. Now, although the effect was much lower than Tesla claimed, the valve is still a useful design, says Ristroff, especially as it has no moving parts, so it can be maintenance free. So things that have moving parts, machinery that have moving parts, need to be oiled, and they basically break over a period of time. Oh, it's broken. There goes my hand, right? Hey, I'm Luke Skywalker. I'm Darth Vader. Woohoo! There we go. But for a piece of machinery, is this a piece of machinery? I don't know. But for something that doesn't have moving parts but still works, that's amazing, right? Yeah, absolutely crazy. Maintenance free, pretty much. Maybe they'll have blockages, inside of it at some point. Debris will go in. I don't know. It has calcium. Calcium residue may get stuck in there. Maybe it might need cleaning every now and then, but that's just my thought. Very interesting, right? It has been known about and has been used in some applications, or at least proposed for use, but no one had ever really done the thorough hydrodynamic work on it to figure out how it works, how well it works, says Ristroff. All right. The team found that there was no difference in resistance between forward and reverse at low flow rates, but instead the valve abruptly activates above flows of around 1 centimeter per second and significantly resists the reverse flow. Amazing, right? Absolutely incredible. Now, Ristroff believes that Tesla, who also had a patent for an AC to DC electrical converter, conceived of the valvular conduit to do the same thing for fluid currents. AC electricity sees electrons constantly reverse their direction, but when converted to DC, they effectively flow in a loop. His team, I was making a loop motion then. His team made a ring of Tesla's water valves to mimic Tesla's electrical converter and found that it successfully took oscillating water, sloshed back and forth by a piston, and converted it into a steady flow of water in one direction, effectively turning it into a pump. Wow. Amazing, right? That's incredible. The team believes that the design could harness the vibrations in engines and other machinery to pump fuel, coolants, lubricants, and other gases and liquids. Imagine that. Imagine like every engine that we turn on with every combustion engine has vibration to it. Imagine utilizing that vibration that's already there and turning that vibration into something useful. Moving liquids, gases around. You're basically using that vibration and turning it into an energy. Wow. That's absolutely incredible. So we'll continue reading that. Okay, imagine if you had those fluid pump systems basically take the vibration from the motor that's there anyway and have that circulated. It has no moving parts. There's nothing to break, says Ristroff. Wow, super interesting. So going back to some of his patents, this is the one we're talking about, at least the Tesla valve. Very interesting conversation, wouldn't you say? Who knows where they take this technology in the future? Rocket engines, pulse jets, who knows, But going back to the Tesla files, that was a very interesting show. It's like a 7-part series type thing, season 1, 7 episodes kind of thing, where they go and they find Nikola Tesla's patents and they read stories about what he did, and they basically try and recreate his inventions. The Tesla coil, the thing that goes flies out electricity everywhere. He obviously invented that. In the show, they talk about the sad fact that he unfortunately died alone in New York City. An old man, didn't really have anyone that loved him. Really sad situation. But a lot of his patents and boxes of inventions might have been stolen by the American government. And believe it or not, Donald Trump's, the ex-president of the United States, Donald Trump, had a sibling. I can't quite remember his name now, but his sibling worked within the government, and his sibling knew about Nikola Tesla back in the day, 100 years ago, and they were potentially responsible for taking some of his patents away from him when he died. So go see the show. There was also one more thing in the show that I wanted to say, was that they had homing pigeons. There were homing pigeons that he had friends, like those were his friends, but the homing pigeons. And there was some talk regarding, was he using these homing pigeons to take secret messages to someone else, whoever that someone else might be, we don't know. But yeah, that was one of his loves in life, was, not just building electric engines and water one-way flow devices, but pigeons. So yeah, a very interesting guy and a very sad end for him. Go watch the show if you haven't seen it already. But guys, we do have 2 social medias on YouTube, 2 and 1. Go check us out if you haven't checked out number 1. We make some good travel vlogs on there. Guys, I've been Tall. My name's Gareth, and I will see you tomorrow's video. Peace out.